Okay, so I'm going to show you how to do confidence intervals using your TI83. Now, let me get out of this. All right, so with the first problem here, we have a standard deviation of heights. Okay, so we're talking about heights, and they're giving us means. All right, so this tells us that we can either do a z-test or a t-test depending on what we know. Z confidence interval or T interval, depending on what we know. If we know sigma, if we know the population standard deviation, then we would do a z-test. If sigma is unknown, then we would use a t interval. So the t-score. So here, if we read through, we have the standard deviation of the population is approximately 3 inches. So we know that. So therefore, knowing this, not going any further, we know we're going to do a z-interval, but it has both, so I'm going to show you both of them quickly. We want to do a 95% confidence interval, so we can figure out our alpha. All right, we know that alpha is going to be 5%, okay, and alpha over 2 is going to be 0.25, so we can look up those pieces if we need to. We have a mean of 71 inches, and we looked at 48 males. So we fill in this information, we had x bar here would be 71, which is our sample mean. Our sigma is 3. Our sample standard deviation, they tell us that, which is 2.8. We know our n is 48, and therefore our degrees of freedom here would be 47. Remember, n minus 1. Okay, for doing a z interval, we don't need degrees of freedom, but if we're going to do a t-score, we would. So, and I'm going to show you both of them because we have both pieces of information. So we turn on our calculators, and we go to stat. Now to do intervals, they're on tests. The reason they're on tests is because the intervals can be used as a quick hypothesis test or quick check for a hypothesis test. If the mean population mean or population proportion is found to be within those intervals, then we would fail to reject the null hypothesis. So it's a check of these. So to do the z interval, we do number 7. To do t interval, we do number 8. And to do, when we're doing proportions, it's letter A here. So we're going to do number 7. Now we have data. They've given us values, so we're actually going to use statistics. Enter. Okay, notice the data says, okay, this is stuff that's in a list. Where is the list? We have been given statistics, so we choose stats. We have to go down, we just type in our values. Our sigma is 3. Our mean is 71. Our n is 48. The confidence level is 95%, so we don't have to do anything. We hit calculate, and it gives us our values. Now to find the error bound is the space between these two. Okay, it's the error around them. So I can just take my higher level here, which was 71.849, and subtract off 71, and I would find that my error bound here would be 0.84 or 0.85, depending on how many places they ask us to round. So that's how we would use a z-interval. Now a t-interval is going to give us a little bit different, all right, because we have to use the t-distribution. And again, we have statistics. We have our mean was 71, but in this case our standard deviation was 2.8. We still have 48 people, and we calculate, and it does our work, and we get, this is our ranges. Okay, so here's 70.187 to 71.813. Okay, again we could find our error bound, 71.813 minus 71, and we got 0.813 or 0.81. So that would be how we would calculate our error bound in this case. Now it's much easier than doing, calculating the little pieces which they would ask you to do. It's your z-score times your standard deviation divided by the square root of n. So, and these things here we can fill in as we go through. So that is how we do confidence intervals for means. Now, if we look at the next problem here, we're going to do a confidence interval for proportions. So we have 6 packages of Flintstones, fruit snacks. There were 5 Bam Bams in each pack, in the packs. There were 68 pieces total, and they want to know the confidence interval of the proportion. They want to do a 96%, which is a weird value. I will give you that. Again, we go statistics, we go over to tests. We have to go all the way down to letter A because we only have one proportion. So here we have to put in our x's. How many things actually happen? And you cannot put in decimal values. You have to have whole numbers. So if you have a decimal, you have to round. So here we found that there were 5 out of 68, and we want to do a 96% confidence interval. Now we can do whatever value with the calculator. We can do any level we want. That's the nice thing about it. And we hit enter, and it gives us a percent. It gives us proportions. It says that there is somewhere between 0.0085 to 0.138. So our proportion is, we found an estimate of about 7%, and it's somewhere between, if we round this to 2 decimal places, 1% and 14% of the values would be Bam Bam, of the fruit snacks would be Bam Bams. And again, we can calculate our error bound by subtracting off our values here, and again, being more as rounding as many places as we wanted. So if I did, 3 decimal places or 4 decimal places or 2 decimal places, I'm going to have different ranges for my error bounds, but I'm just going to subtract them. So I'm going to do 0.13853 minus 0.07, and I have 5 decimal places, so I'm going to do 5 decimal 7, 3, 5, 2, but I'm going to round that up to 3. Enter. So my error bound was about this, about 0.065. So that's how we calculate our error bounds. Same way we do for the means and means with either the t interval or the z interval. Hope this is helpful. See you next time.